Metallic mystery. The puzzling silence of a strange metal in quantum noise experiment. Rice physicists find evidence of exotic charge transport in quantum material. True to form, a strange metal quantum material proved strangely quiet in recent quantum noise experiments at Rice University. Published on November 23 in the journal Science, the measurements of quantum charge fluctuations known as shot noise provide the first direct evidence that electricity seems to flow through strange metals in an unusual liquid-like form that cannot be readily explained in terms of quantized packets of charge known as quasi-particles. The noise is greatly suppressed compared to ordinary wires, said RIA's Douglas Nadelson, the study's corresponding author. Maybe this is evidence that quasi-particles are not well-defined things or that they're just not there and charge moves in more complicated ways. We have to find the right vocabulary to talk about how charge can move collectively. Experiments on quantum critical materials. The experiments were performed on nanoscale wires of a quantum critical material with a precise 1:2 ratio of ytterbium, rhodium, and silicon, Yber2C2, which has been studied in great depth during the past 2 decades by Silke Paschen, a solid-state physicist at the Vienna University of Technology, TU Wien. The material contains a high degree of quantum entanglement that produces a very unusual, strange, temperature-dependent behavior that is very different from the one in normal metals such as silver or gold. In such normal metals, each quasi-particle, or discrete unit, of charge is the product of incalculable tiny interactions between countless electrons. First put forward 67 years ago, the quasi-particle is a concept physicists use to represent the combined effect of those interactions as a single quantum object for the purposes of quantum mechanical calculations. Theory and empirical evidence. Some prior theoretical studies have suggested that the charge in a strange metal might not be carried by such quasi-particles, and shot noise experiments allowed Nadelson, study-led author Liang Chen, a former student in Nadelson's lab, and other Rice and TU Wien co-authors to gather the first direct empirical evidence to test the idea. The shot noise measurement is basically a way of seeing how granular the charge is as it goes through something, Nadelson said. The idea is that if I'm driving a current, it consists of a bunch of discrete charge carriers. Those arrive at an average rate, but sometimes they happen to be closer together in time, and sometimes they're farther apart. Theoretical perspectives and future implications. Rice co-author Kai-Miao C., the lead theorist on the study, and the Harry C. and Olga K. Weiss Professor of Physics and Astronomy, said he, Nadelson and Paschen first discussed the idea for the experiments while Paschen was a visiting scholar at Rice in 2016. C. said the results are consistent with a theory of quantum criticality he published in 2001 that he has continued to explore in a nearly 2-decade collaboration with Paschen. Nadelson said the larger question is whether similar behavior might arise in any or all of the dozens of other compounds that exhibit strange metal behavior.